This lesson is about calculating percentage strength solutions. We'll start out with a little bit of meme humor today, so take a moment to appreciate this meme. Calculating percentage strength solutions is really easy once you memorize one simple equation. And that equation is C1 times V1 equals C2 times V2. Each one of those variables stands for what's listed below here. C1, the concentration of the original solution, V1, the volume of the original solution, C2, the concentration of the final solution, and V2, the volume of the final solution. Step 1 of this process is identifying the known variables. So here I'm going to provide you with a sample problem. If 500 milliliters of a 30% solution is diluted to 600 milliliters, what will be the percentage strength of the solution to the nearest hundredth? So let's look at the concentration first. Concentrations are always expressed as a percentage. Those are our C's here. C1 is the starting point and C2 is the ending point. So when you're diluting, you'll start with a higher percentage and you'll end with a lower percentage. In this situation, C1 is 30%. And as you notice, there's actually only one percentage given in this problem. So C2 is the unknown. We want to determine the percentage strength of the resulting solution. Now let's take a look at the volume. Volumes are always expressed in milliliters, or the abbreviation ml. V1 being the starting point, V2 being the ending point. Dilution, by definition, means you're adding additional volume. So when you're diluting, you start with a lower volume and you end with a higher volume. So in this case, we know V1's 500, the lower volume, and V2 is 600, the higher volume. So now we've identified the known variables at this point. C1's 30, V1's 500, V2 is 600. Right now we're doing step 1 practice. This is an entirely different problem, but what you're to do is to complete step 1 independently, identify the known variables for this problem. Don't proceed to the next slide until you finish completing step 1 for this problem, so feel free to pause it after I read it. If 350 milliliters of a 35% solution is diluted to 550 milliliters, what will the percentage strength of the resulting solution be to the nearest hundredth? So here we're doing step 1, identifying those known variables again. C1, that concentration of the original solution, is 35. The volume of the original solution is 350. Concentration of the final solution is unknown. We don't know what that second percentage is. And the volume of the final solution is 550. All right, we're moving on to step 2, back to that sample problem here that I'm using to model. So now we can plug those known values that we determined back there in the beginning into step 1 of the equation. C1 was 30, V1 is 500, and V2 is 600. Remember, that was that initial values that we came up with. So we're just going to substitute them in. Put 30 in for C1, 500 for V1, and 600 for V2. And you can see that we're left with only one variable, that's C2 now. Okay, now we're going back to that individual practice now that it's been modeled. So don't proceed to the next slide until you've completed step 2, replacing known variables with known values for this problem below. Feel free to pause once I've gotten to the end of this slide. If 350 milliliters of a 35% solution is diluted to 550 milliliters, what will be the percentage strength of the resulting solution to the nearest hundredth? Again, here's where we left off. C1 was 35, V1 was 350, C2 was unknown, and V2 was 550. Feel free to pause at this time. So we're just replacing those known variables with known values just like we did before. Putting 35 in for C1, 350 for V1, C2 staying where it is, and 550 for V2. So that once again, we're left with only one variable now. Okay, moving back to step 3 for this original sample problem. So just follow along here. So now we have that equation for step 2. Now we have a solvable equation and we can perform the third and final step of the percentage strength solution calculation process. Okay, you can feel free to use a calculator for this part. We're going to begin by multiplying 30 and 500 for a product of 15,000. Okay, next we divide both sides by 600 in order to isolate that variable, okay? And you can see there on the right side of the equation, we can cancel 600 over 600 because that's equal to 1. Now, once again, you can use that calculator to divide 15,000 by 600 to get your final answer, that percentage strength or concentration of the final solution, which is 25%. That's your final answer. That's what we were looking to solve this whole time, was that C2 value. Okay, now again, some step 3 practice. Again, do this independently. Don't move on to the next slide until you have completed step 3 and finished this problem out. If 350 milliliters of a 35% solution is diluted to 550 milliliters, what is the percentage strength of the resulting solution to the nearest hundredth? This is what you've been trying to determine all this time. Again, here's where you left off. Feel free to pause at this time. Alright, so you can see we just repeated that same process again. We multiplied 35 times 350 and got a product of 12,250. Next, we divided both sides by 550 to isolate that C2 by itself. 550 over 550 cancel because it's equal to 1. And then we can do that last thing in our calculator, 12,250 divided by 550 for our final answer of 22.27%. Alright, don't forget to round to the nearest hundredth. That's our final answer. Right, now we're moving on to more practice problems. And just like with the other practice problems we saw, do pause after I read the question so that you have some time to work before getting to that solution. You're to prepare as much 40% dextrose solution as you can from 200 milliliters of 70% dextrose solution. To the nearest hundredth, how many milliliters of 40% solution can be prepared by diluting the 70% solution? We have multiple choice answers in this situation. A, 325 milliliters, B, 275 milliliters, C, 312 milliliters, or D, 350 milliliters. You can pause to complete this problem at this time in its entirety. And the correct answer was D, 350 milliliters. If you got the right answer and you feel confident and that you don't need to see a detailed solution, you can go ahead and skip ahead in this video to the next practice problem. But if you didn't get it right, I highly recommend that you look at this step-by-step solution on the upcoming slides. Step 1, we're identifying the known variable. The concentration of the original solution is 70. The volume of the original solution is 200. Concentration of the final solution, remember it's that lower percentage, 40. And V2 is what we're looking for. We were only given 1 milliliter value. So the volume of the final solution is unknown in this case. That's what we want to find out, V2. Moving on to step 2, we're replacing those known variables with known values. So we can plug in our values from step 1. 70 for C1, 200 for V1, 40 for C2, and we're leaving V2 how it is because that's our unknown variable. Finally, step 3, our third and final step, we're solving for V2. We multiply 70 times 200 for a product of 14,000, divide both sides by 40 to once again isolate that variable. And lastly, we do 14,000 divided by 40 equals 350 milliliters. That is our V2, what we have been looking for. On to the next practice problem. To the nearest hundredth, how much 40% solution is needed to make 500 milliliters of a 5% solution? A, 125 milliliters, B, 62.5 milliliters, C, 75.5 milliliters, or D, 625 milliliters. Pause at this time. The correct answer is B, 62.5 milliliters. Once again, go ahead and skip ahead to the next practice problem if you got this right and you feel confident in your answer. If you didn't, I highly recommend you look at the step-by-step solution that I'm about to show you. So we'll begin by identifying those known variables. C1, the concentration of the original solution, is 40%. V1, our volume of the original solution, we don't know. It's unknown. We want to know how much 40% solution we need. C2, the concentration of the final solution, that is 5. And V2 is the volume of the final solution, 500. Step 2, replacing those known variables with known values. We put 40 in for C1. We left V1 how it was because we don't know that value. 5 in for C2 and 500 in for V2. Now we need to solve this equation for our unknown variable V1. Multiplying 5 times 500 gives us 2,500. Divide both sides by 40 to isolate the variable. And then we ultimately get 62.5 milliliters for our V1 value. One more practice problem. You need to make 150 milliliters of a 20% solution. To the nearest hundredth, what is the concentration of the original solution if you start with 50 milliliters? A, 60%, B, 37.5%, C, 6.67%, or D, 45%. Please pause at this time. The correct answer is A, 60%. Go ahead and bypass the solution process here if you got it correct and you feel confident in your answer. But if not, go ahead and take a look at this step-by-step solution we're going to show. Step 1 is identifying the known variables. The concentration of the original solution in this case is unknown. We knew what we needed to make, but we didn't know what that original solution concentration was. The volume of the original solution was 50. Concentration of the final solution was 20, and the volume of the final solution was 150. Remember, it's a larger value than the original. Step 2, replacing those known variables with known values. C1, remaining that variable, 50 in for V1, 20 in for C2, and 150 in for V2. Finally, we can solve our equation. 20 times 150 gets us a product of 3,000. Divide both sides by 50 to isolate that variable, and we get a final answer of 60%. At this time, you are to complete the assessment and evaluation. Do not view this presentation while answering assessment questions. The only resource you should be using is a calculator. So you'll begin with that 5-question assessment. It's multiple choice. You will receive feedback on that. And then you can conclude with that evaluation. Thank you for watching.